So if something's compounded continuously, then the amount you have after a certain amount of time is equal to the principal times e to the RT power. And so for this one, it's compounding continuously. What would be the value if this continuous stream of the person retires at the age 65? You got to plug in $6,000 for the principal because that's the starting amount. And then the rate is 1.2%, so that'd be 0.012 in for R. And then they're going to be 65, so we're talking about a 35-year span, starting at year 0, ending at year 35 with respect to t. So when you find this antiderivative, you got to consider what happens with the derivative, right? If you were to take a derivative of 0.012 is going to come down and multiply and mess this up, right? So with the antiderivative, you want to do this. Because the derivative of the innermost function is going to be 0.012. So we want to make sure that cancels out if we were to take a derivative so that we would return to what we started with. So there's our antiderivative. We can clean it up a little bit because we can divide by 0.012. That's 500,000. So we can plug in 35. And then if you plug in 0, it's e to the 0 power, so that's 1. So it's just going to be subtracting 500,000 here. So 35 times 0.012. Wait, did I get that right? Yeah, that is 0.12. So we want to put that on top of a power of e, so I'm going to hit my e button. That's e, the exponential constant. Raise that to the power, and times 500,000. Oh, I did 5 million. So times 500,000. So it's $760,980.77, but we got to subtract that 500,000 that came from the second part of our integration. Did they say round? Round your answer to the nearest integer. So this rounds up. There's our answer.